Next up, we have Eric Schmaus from Intel. He'll be speaking on from runtime to compile time, improving ASL through enhanced namespace resolution. And there you are. Thank you. You might need this. Thank you.
And with this slide. Hello, my name is Eric Schmaus, and I am a part of the ACPI CA group at Intel. ACPI CA is an open source software project that is OS independent, and we provide firmware tools as well as an implementation of the ACPI specification. Today I will be talking about a new feature that we've added in our compiler. But before I do, we'll go over a brief overview of ACPI. So what is ACPI? It is a firmware interface that is used by the operating system, and it enables device discovery, initialization, as well as configuration. And it also enables things like OS power management during OS runtime. So the ACPI specification also outlines firmware data tables, which can be thought of as key value pairs, as well as an executable bytecode format called ACPI machine language, or AML for short. So yes, and you heard that right. So this is the bytecode that I'm talking about is similar to other programming language bytecode, such as Java bytecode. So for example, if you were to program a Java program and compile it, what happens is that it translates to this bytecode representation called Java bytecode, and that is run on a bytecode interpreter that is a user space application. This is similar for Python and many other languages. And so here is a rough diagram. So the bytecode interpreter actually runs in OS kernel space for most operating systems. And so what happens is that during initialization of devices and device configuration, the device driver framework may query this bytecode interpreter that has access to these values as well as bytecode in ACPI tables. So if you are new or have not heard of ACPI before, imagine that an operating system device driver framework with a bytecode interpreter, like something like a Python interpreter, just crammed inside there. And that's what an ACPI-enabled operating system is from a very simplified view. So we're talking about these ACPI tables. Well, how did they come to be? Well, firmware developers start with some sort of hardware specification, sometimes called a data sheet, and that is translated by hand or maybe by some program to this language called ASL, ACPI source language, which is compiled to ACPI machine language, then combined together to what we call the ACPI tables. And there can be multiple ASL files, which results in multiple AML files, which get combined into there to result in what we have right here. So here is a brief sample of ACPI source language. This defines a language construct called the definition block, and inside there are many kinds of named objects. So there is, for example, in this diagram here, in this code snippet here, there is a device object called dev1, as well as an integer object called ADDR and a method called mth1 that takes one parameter, and it does some math and returns an integer value called int1. So what happens is that as the operating system boots up and it needs information from the ACPI subsystem, the OS kernel will call into the AML interpreter, and these objects get evaluated. So looking at it here, ADDR is just a static value. It can also be written, but ADDR can be fetched, but MTH1 can also be evaluated. So each statement will be executed by this bytecode interpreter. So what are some issues that we come across? Okay, well, since this is executed on a bytecode interpreter, there can actually be runtime errors. All right, and so now let's think about the context of all this. This is during device initialization, configuration, putting devices into certain states. These interpreters write to different registers. So these runtime errors may be very serious. It could prevent devices from being in certain power states, as well as loading firmware tables. If things don't make sense in this space, OS runtime, the operating system during runtime may have a lot of difficulty. So, what are some of the common runtime errors? One type are called type errors. So, for example, if we try to add an integer to this thing called the device object, it doesn't really make sense, and this is not allowed by the ACPI specification and will result in a runtime error. Now, this particular line of code is actually caught by a compiler, but this is more of like a simpler example. There are more complicated examples that make it hard to compute that will result in the runtime error, but this is just for an example. There are out-of-bounds errors. So in ASL, you can declare byte arrays. So let's say that I declare a static length of 3, and we index to index 99, for example. That will be also a runtime error. It's not like we can go out of bounds and just access things willy-nilly. This should not be allowed. Right. In some cases, certain operating systems might permit it, but either way, it's an error. And the last kind of error are called namespace resolution errors. So in this case, the objects or these variables referenced in the ASL and AML are undefined or they're redefined. So, and this tends to happen across multiple ACPI tables. So in the case that there are multiple bytecode executable tables that refer to each other, maybe there may be some issues there. So how does this happen? Well, ASL contains a language construct called external, which is similar to the C external, and tells the compiler that a certain object is declared in a separate ACPI table. So for example, in this example, we have this device called dev1 that is external in a file called dsdt.asl, and ssdt.asl declares this device called dev1. So that's the proper usage. However, currently, ASL files are compiled one at a time separately. So there are no guarantees that these symbols are resolved after a compilation of a single file. We just say, hey, promise me, like I promise, compiler, well, this thing exists. So as these tables get more complicated, these errors are harder and harder to detect. Now, this small example is fine, but as we get into tens of thousands, I've seen ASL tables that are about 1 million lines long as well for some servers. Things get complicated. So at OS boot time, all of the ACPI tables, sorry about that. So what happens? So let's say that we compile some files that contain external references, but their references do not actually exist. Well, what happens is that at OS boot time, all the ACPI tables are loaded, and these non-existent references are exposed. So we find this out at boot time, which is which is kind of painful if you think about the development process. We write ASL code, we take a long time to build the firmware, and then we finally boot to find this error. Right? In addition, there are also redundant objects that can be detected during OS boot as well. So how can we solve this issue before we boot the operating system? And one solution could be to use something like a linker. And so the whole idea with this is that we should be able to catch these errors during compilation as a part of linking, during development, right? But not all ASL compilers emit AML external opcodes for the named objects that are declared external. So with languages like C, we have these object formats that tell the linker that certain symbols are declared in other files, and the linker knows to go fetch these names. But in ASL, we don't really have that kind of standardization. So we can't just take arbitrary AML files and combine them together and hope that it's okay. There could be some files that are, there could be certain names that are not declared. So another solution is to use an interpreter. So as a part of ACPI CA project, we have this user space version of the AML interpreter called ACPI exec. Now this can help us resolve these object names as well as execute each control method, as well as evaluating all these names. However, we need to actually be able to test each and every single code path. So we need to be sure to generate test cases that will go through every single possible execution path. Because maybe in some execution path, there may be a reference to a name that will remain kind of dormant until the operating system evaluates the method in a certain way that will trigger this error. So these are almost like hidden landmines in some ways, and using an interpreter, we need to be able to do that. Now, I'm not saying that ACPI exec or user space interpreters are a bad thing at all. It's just to detect this kind of error in a methodical way is very difficult to do. So another solution is to add kind of conditional statements or guards within ASL to check for certain symbols, to make sure that certain symbols exist before we continue with the method execution. So this entails adding an if statement saying, okay, this name is declared external, and if it is, or if this named object exists, then we will execute this certain code path. And I think this is a pretty good approach as well, pretty good approach to avoiding these runtime errors. However, it adds complexity to the ASL code. Maybe, so we have to take care of an else case as well for any sort of control method. Maybe certain methods should not be exposed or exist if if some variables do not exist. So although this is valid solution, it might not work for all, for any arbitrary case. So in order to tackle this problem, my solution is to alter the ASL compiler. Okay, so just about everyone who writes ASL uses ISL as a part of their build. So modifying ISL is a solution that does not require a complete overhaul of the firmware build system. And so we have recently completed a new ASL compiler feature that allows the compilation of multiple ASL tables in the same namespace. So what does this mean? So previously, the following command actually compiled each file in separate namespaces. So this command is as if you were saying iasl dsdt.asl, and then press enter, and then iasl ssdt.asl, and press enter. So this command is equivalent to doing that separately. So now the above command assumes that all files compiled together are meant to be packaged together as a set of ACPI tables for the OS to boot. So this changed a few things. So all named objects in use must be defined. So if there is an external, if there is a named object that is declared external and it is being used, but it is not defined, then it is illegal. As well as duplicate named object definitions are not allowed. So this is a change. So if you are compiling ACPI tables in this manner, you may get additional errors. So here is a simple example. So let's say that I have these two, actually, let's just focus on this one. So I have one table, one firmware table that declares int1 as an integer object, and a method called ds1 that will just return the incremented version of int1, as well as a named an object called obj1, and the second table that declares obj1. So if we were to try to boot to compile this together, or boot an operating system on these sets of ACPI tables, then we when ds1 is executed, then we will incur a runtime error because int1 does not exist, as well as object1 is a redeclaration. Oops. So previously, if we were to compile this file, then we would get this kind of output. Notice that this compilation succeeds and generates bytecode. So this is quite dangerous because now if we try to boot an operating system in this way, we will incur a runtime error. As well, and what's even more dangerous is that one runtime error, the obj1 would appear. However, the int1, we will not find that out until that method is evaluated. So now, in the new feature, using the new feature, we have two errors. Let's say that int1 is indeed declared external, but the actual definition does not exist, as well as object1 is a redeclaration. So, and most importantly, this compilation does not generate bytecode. So you can't, so if we have like a clean build and you try to compile using this, we won't generate bytecode for the operating system to boot on. So we've moved the runtime errors as a compilation error. So that's exciting. So this, yeah, like I said, enables ISL to detect duplicate symbols and existing ones. So yeah, we've also, using this compiler feature, we've eliminated two of these most serious runtime errors. So what is my takeaway from this experience? We need to create more features in IASL or make changes in the ASL language itself so that the compilers can detect more runtime errors during compilation. And these things may require firmware developers to improve existing ACPI firmware if they use this feature. And we also need feedback on what can make ASL programming easier. So that is all for my presentation. Any questions? Yeah.
You said in the last slide, may require people to improve their ASL code.
Yeah.
Don't you really mean to get rid of their bugs?
Yes. To remove bugs, yes.
That's all.
I think that's an improvement.
Yeah. But it's hardly a It's more of a pro.
Oh, yes, yes, that is true, yeah.
So does EDK2 currently optimize ASL builds so that for a given INF file so that they're all combined on a single command line to enable this feature?
So this feature, actually, we released this like last week, so not yet. Yeah, and so so the next step is for me to work with people to to help use this feature, and there's multiple ways to use it, and so I'd be gladly willing to show you guys a demo during office hours. By the way, those office hours are at 3 to 4 right here. So yeah, another way so let's say your build system is extremely complicated and you have, you have like 5 repositories that generate code firmware for 120 boards or something like that. We could, one thing that we could do is to disassemble all of the ACPI tables and then recompile them to see if these errors exist as well. So that's another option.
Right, so I'm looking at a typical build system involves ASL files in an INF, and I want to make sure that EDK2 supports it. That's the first question. Second question is, what if I need an exception to the extern rule? For example, I've got an SSDT that's provided by a third party, such as, let's say, Intel provides me an SSDT that's compiled in a binary, and it's not compiled together at the same time. How do I make an exception so that these particular objects will external successfully?
That's a good question.
Yeah, so let me just, so there are cases, you're right, in most cases we take a big glob of ASL codes and we do put them together exactly the way that you described, but there are at least a couple drivers that are producing named objects that I still need to access because they're provided by a third party.
Right.
So it almost seems like we need an extension to the extern syntax to almost force it to be a real external. Because I want it to be the exception because I do value these improvements because they do catch a lot of things that I see on an every day-to-day basis.
Yeah, so for now, like without making changes to any of the specifications, you can disassemble that and then recompile as well. I believe that we need to kind of trend towards eventually, it would be ideal to have a final compilation with everything, so that these references do exist.
We have multiple people who contribute to putting together the system firmware, and that includes multiple people who provide the ASL code.
Right.
And many times we always see is the AML side. So unless AML has a way of describing at some point the external object, I need to have a way to get around this rule. Otherwise, I can't even build my BIOS using the great stuff that you've added here. So that's what we can talk about. We can talk about offline.
So I think we can talk about the disassembly and what that entails.
But I don't. My average ODM is not going to say, sure, I'll boot the system once and then create an ASL file and then recompile it again because as part of their build process for making their average BIOS. So I'm trying to come up with a workable solution for the average, for the working model.
I'll second Tim's.
Okay, thank you.
Tim's. The
Okay.
files are not always built all together.
Yeah. Okay. So that's definitely something to work on there. So, yeah. Thanks. Any other questions? Oh, I forgot to look this way. Yes. Yeah.
My wife is still out. I don't really know if this is required, but is there a binary release of this updated ASL so that we can test it on our code basis to find out if this is causing a problem and if we need to discuss more about options?
Yeah. So right here, it is a part of the most recent ACPI CA release. So feel free to go and download it and test it out.
Okay, the binaries are up.
Yep, the binaries are out.
Okay.
Yep.
So I don't know if this is really the right context to bring this up, but while we're talking about runtime issues with ACPI, I'm wondering if you guys have considered adding compiler time and runtime auditing features for security verification so that you don't have things like
So I think, so to answer your question directly, no, but that's what I mean by we can add features to ASL. And so certain language features will hopefully avoid things like that as well. But there isn't, so what happens when you incur a runtime error during the control method execution is that the method is aborted right away. It's not like if we go out of bounds, it's not like, see where you expose a security hole. Yeah.
Is that security enforcement happens to the interpreter?
Yeah. So we fail, right? And then it'll continue. Yeah, go ahead.
So there are guards in place, essentially, but it's up to the operating system developers writing the ACPI driver for the ACPI interpreter to ensure that boundaries boundary checks are enforced.
Either that, or we can also do it at the ASL level too. For example, if we want to index into something, then let's say that we have an index, we can check that index to make sure that it isn't within bounds. We have a size of operator. So it's about how to make that easy to program. For example, if we want to loop over each item in the list, we can provide like a for each kind of macro in a way that allows the ASL to loop over each item in list without going over the boundaries.
That's only good if you're producing something like a signed AML file, right?
Yes. So yeah, it's a solution for the firmware developer. Yeah, it's for the programmer. Yeah.
Okay, thank you.
So, just to clarify, this feature is on by default, and there's no way to turn it off in the latest phase of the file?
Yeah. And so if you like the other way, where you're compiling each file separately, the idea is that maybe you could perform separate commands. Because that's what you're doing.
Yeah.
So.
If we do it as one file, I can still try to verify all namespaces are available.
So if you do it as one, so that's a good point. Thank you for bringing this up. So if you do it as one file, then we honor the external and believe that it is somewhere else. Yes. But so that's why I said the assumption is if you compile multiple now, it's a set of things that work together. Any other questions?
But to Tim's point, that it's a set of things that are expected to work together, but it's also expected to be a complete set of things.
Right, but it also means that you can add things on top as well, right? And if there are ASL files that contain externals and they happen to exist, that's also works as well. If let's say you're adding a file to this set. Yeah. So there are so this is ACPI in general as well. The data tables contain references to the ASL and vice versa, actually, with the new PCC operation region, actually. We need to actually be checking each other. So the data tables against the ASL and ASL against data tables. So I think the next logical step is to also be able to compile the data tables along with the ASL to improve checking. So, yeah.
So adding to Tim's point again, the conditional reference check will still work, right? If you have multiple tables being generated together in the same namespace, does the conditional reference check still, is it still valid? So
I think it still is, but maybe sometimes, and so I'm taking a look, my perspective is very broad, and so it's more for any general. But I think it is valid if if there is a control method that works with, let's say it turns off this particular device and that particular device. And if you don't have one of those devices, then, oh, well, we can just move on and turn off the other device. I think that's a very valid case, but it may not be for all.
Yeah, I mean, I'm just trying to see if his point is still covered or not, because if there is a table that he's expecting from a third-party binary, right, I can still have a conditional reference check even though I've built multiple tables in the same namespace. If I have a conditional reference check for the third-party object, then my table should still be, my ASL should still be compiled without any errors.
Yeah.
Right.
So there seems to be a use case, that I'm, might have not taken into account. So we can definitely talk about these things during office hours or other times as well.
Yeah, so it's about 11:30 now. We should move on to the next presentation. You have a whole hour at 3 for the office hours. Continue on any discussions.
All right. Thank you.